Differentiation is an essential concept of calculus. In this video, we will delve into the fundamental principles and methodologies of differentiation, designed to equip you with a firm understanding of its significance in mathematical analysis. Let's take a step back and understand why differentiation is such a crucial aspect of calculus. Differentiation is all about studying how a function changes or how its values shift as we move along its graph. It allows us to calculate the rate of change, the slope, or the steepness of a function at any given point. Imagine you're looking at a curved graph, representing some function. At each point on that curve, we can draw a straight line tangent to the curve. The slope of that tangent line tells us how rapidly the function is changing at that specific point. Now let's get into the intricacies of differentiation and explore the process step by step. What's the first step in differentiation? Well, we start with a function, let's call it fx. Our ultimate goal is to find the derivative of this function, which represents the rate of change of fx with respect to x. To begin, we'll introduce you to a special notation used in calculus, the prime notation. The derivative of fx is denoted as f prime of x. If fx is a simple polynomial like 3x squared, its derivative, f prime of x, is obtained by multiplying the coefficient 3 with the power 2 and then reducing the power by 1, resulting in 6x. But what about more complex functions? There are three fundamental rules that are useful to understand. The first rule is the power rule. For any term x to the power of n, its derivative is n multiplied by x to the power of n minus 1. So, if we have x to the power of 3, its derivative will be 3 multiplied by x to the power of 3 minus 1, which is equal to 3 times x to the power of 2. The second rule is the constant rule. When we have a constant term, like 5 or pi, its derivative is simply 0. So if we differentiate fx equals to 5, its derivative, f prime of x, will be 0. The third rule is the sum rule. When we have two functions added together, we can differentiate each term separately and then add them up. For example, if we have fx equals to 3 times x to the power of 2 plus 2x, its derivative f prime of x will be 6x plus 2. To summarize, differentiation is the core concept of calculus that helps us understand the rate of change of functions. We've explored basic rules like the power rule, the constant rule, and the sum rule, which make differentiation manageable.